The first is when you're comparing two sets of numbers and you're trying to find the difference. Which one is bigger, how much, which one is smaller, how much. Second situation is when you want to take something away. If you're taking something away, you're making your total smaller, which would be subtracting. And the third situation is when you have a missing part of a whole. You know what that whole total is, and you know what part of it is, but you haven't figured out what that missing part is. Let's work through some examples together. When we're comparing numbers, we typically want to subtract. For example, here I have a problem that states Mrs. Ketchum's class is 25 kids, Mrs. Dieter's class is 27 kids. How many fewer kids are in Mrs. Ketchum's class? I'm comparing these two numbers. I know that my difference is going to be relatively small because 25 is close to 27. If you're using bar diagrams to visualize, I would start with this bar representing the total number of kids in Mrs. Dieter's class. And I know that in Mrs. Dieter's class, there are 27 kids. That is my total. I know that out of those 27 kids, this would be the length that would be Mrs. Ketchum's kids. There's 25 kids here. What I'm trying to figure out is the difference, just this small little section right here. To figure out that small section, I would take Mrs. Dieter's total class of 27, subtract out 25 kids, which would be equal to Mrs. Ketchum's class, and then that would help me to know how many were different. If you did the math yourself, you'd end up realizing that the difference is 2. Another situation where you're subtracting is when you're taking something away. Here's a sample problem. We started the day with 35 sharpened pencils. By lunch, 17 of the pencils had been taken to be used by the students. How many pencils are left? Again, if you want to use that bar diagram, you can visualize this whole bar right here is our total of 35 pencils for the entire day. Some of these pencils have been taken away, though. We know that 17 pencils have been taken away. If it helps you to visualize, you can even X those out so you realize that those are the ones that are missing. It's this other smaller portion that we're trying to figure out. To solve this problem, then, I would take my total of 35, subtract out the 17 that have been missing, and that should leave me with my last little piece. The last time when you want to subtract is when you're missing a part of a whole. Here's a sample problem. 53 kids are jumping in a bounce house. If 28 are girls, how many are boys? Well, the 53 again represents the total number of kids who are jumping, so I can write that on top here. That is my total. I know part of the total is girls, so within this number, I know that part of them, 28 in fact, would be girls. What I'm trying to figure out is the other part, which would be my boys. So in summary, when you're subtracting, you're doing 3 things most likely. You're either comparing numbers, taking something away, or missing a part of a whole. You know that you're subtracting because the number that you're getting as your answer is smaller than that total sum. And you can use a diagram to help you to see what is the total and what is the missing part. Because if there's a missing part, you know you're subtracting. Go ahead and look at some word problems and see if you can identify when you're subtracting.